Okay, today we'll be going through the very first revision booklet. All right, post prelim practice. Let's go. Question 29. The diagram shows the life cycles of organism P and Q. All right. So based on the diagram, state one similarity and one difference. Now, whenever you look at life cycles, right? If you see a stage, okay. This is the pupa stage. If you see a pupa stage, it means that it is actually a 4-stage cycle. That is one thing that you can use to help yourself differentiate between a 4-stage and a 3-stage. Now, there are certain things that you need to note about life cycle. You need to know a few insects there is 3 stages. So things that are 3 stages, okay, will include things like your grasshopper. So your grasshopper, this is 3-stage, okay, your grasshopper, all right, as well as your cockroach. Okay, and the interesting thing is that the young will look like the parents. The only difference is that it does not have wings. Only the adults have wings, and the young is known as a nymph. Okay? Now, whenever we talk about life cycle, the exams, they always like to talk about mosquitoes as well. So mosquitoes is 4 stages, and you need to know that there is a stage of it that is in water, just like a frog. However, the frog is actually a 3-stage organism. All right? So what are the similarities? So the similarities, right, will be that both the young, okay, of organism Q and P, they do not look like the adult. All right? P and Q do not look like the adult. Now, the difference would be that the life stages are different, right? So whenever you talk about difference, you need to use comparison words such as but, however, okay? Contrasting words. So for this one, you would say that P has a 3-stage life cycle, while Q has a 4-stage life cycle. Okay? That is one difference. What is another difference is that you can also see that for all the stages of Q, it is actually on land. But however, for organism P, there are actually 2 stages of it that is in the water. Now, both organism P and Q lay many eggs at a time. Explain the advantage of laying many eggs. So we need to remember that you cannot say to increase the chances of hatching an egg. No, that's not true. Actually, if you leave the egg there, whether it hatches or not, the percentage is the same, unless you genetically modify the eggs such that it's able to, say, withstand higher temperatures, or have shorter incubation period. So yes, that is increasing the chances of the egg. What you meant to say, all right, is that even if some of the organisms, P and Q eggs gets eaten by the predators, there is still some that will be left to continue the life cycle. It becomes adult and continue the life cycle. All right, so you want to say that, okay, to ensure that even though some of the eggs might be eaten by predators, some eggs will still hatch and develop into adults to continue the life cycle. Okay, next. How do the organism pea and its young breathe in water? So be very careful. In this question, it is not asking you for a similarity, even though it looks very as if they are asking for a similarity. No, they are asking you how each of them breathe. So you can say the adult breathes two ways. Okay, through its skin, while the young breathe through its gills. Okay. Next. Okay. Tom conducted an experiment to find out how the number of leaves affect water loss by using a setup below. So straight off the top, we know that number of leaves is your change variable, and your measured variable would be volume of water. Now, going to very quick revision. So the oil here basically prevents evaporation. Okay, so this is to ensure that any water loss is due to the number of leaves and not to evaporation of water. That is the purpose of the oil. Okay, so after some time, Tom observed that the amount of water left in setup S was less than setup T. Explain the difference. Okay, so whenever you do this, always ask yourself, what is the difference? So the difference here would be the leaves, right? So then ask yourself, leaves, what are the functions? Two functions. Functions of leaf number one, photosynthesis. We are very familiar with that. Function number two, it is to carry out gaseous exchange via your stomata or tiny openings. Now this gaseous exchange, don't forget, you also have water vapor being lost or water loss in the form of water vapor. So probably that is the key idea. So they ask you to explain the difference. Whenever they ask you to explain the difference, you have to state the difference. Okay? So how would the answer look like? So you want to say that, okay, S will have more or less water left, correct? Set up S has less water left. Then you explain why. As the plant in S, it is okay not to say set up again, that's fine. Save time during exam. Has more leaves, more water is taken up and lost through the leaves via stomatas. Okay, so if you are good, you can use stomata. Don't know how to spell stomata, use tiny openings. There is an alternative answer which is secondary to it. Okay, you can actually say that more water is taken up for photosynthesis because photosynthesis require water. That is also required. That is also accepted. However, if you ask me, water loss is actually a more prevailing answer in this case. It's a better answer because remember, function of stomata is to have water loss. Okay, next. Tom observed that during the colder and darker months, alright, the leaves fell off most trees. However, the trees continue to survive. Based on Tom's experiment in A, explain how this adaptation helped trees to survive. So whenever they say, oh, based on the experiment from above, take a look at the previous one. What are they talking about? They're talking about leaves and how it actually causes water loss to hasten. So in this case, obviously, the less leaves there are, the lesser amount of water is left. And this is important. Why? Because during the colder months, perhaps you didn't know, because Singapore doesn't snow, doesn't have winter. During the winter months, right, unfortunately, all the usable water is now frozen solid. It cannot flow. So because of that, even though there is snow and there's ice everywhere, it is not in a form whereby your roots can absorb. So your tree has to conserve as much water as possible. Okay? So therefore, the answer is to avoid or reduce water loss through the leaves. Okay, that's about it. Next, after colder, darker months have ended, explain how trees will continue to survive. Okay, so obviously to survive, right? The word here survive, it means food. Okay, it's as simple as that. Whenever you have adaptation, remember the three things I tell you. It's either food, increase defense, increase reproduction rate. So in this case, it's quite obvious that we're talking about food. So for food, the plants obviously need leaves. So basically, you need to say that the leaves will grow back okay, and then what happened would be to carry out, let's go back, to absorb light and carry out photosynthesis. Okay, so photosynthesis includes making food already, but between photosynthesis and making food, photosynthesis is the higher order one. Alright? Next. Okay, this question. So this question is on food carrying tubes and water carrying tubes, alright? A scientist identified some female insects and their eggs on this plant. Diagram A shows an insect feeding on the stem of the plant. Diagram B shows a cross section. So what happened is they took this, they cut this, and then they look from it from the top. That means they look downwards, and this is how it looks. Let's do a very quick revision. The one that is inner, alright, over here, which I'm coloring, okay, no, maybe this is a wrong color, in blue. This is actually your xylem, also known as water carrying tubes. Of course, higher order answer is xylem. And then the one that I'm coloring in red would be your phloem, also known as your food carrying tubes. So how do you actually recall? So remember, human can survive about a week without food, whereas a human can only survive, I think, about 3 days without water. So your water is actually more precious, so it needs to be protected, hence it's located inner. Whereas your food, you can do without food. Okay? And also remember, for a plant, right, water is more precious than food, because as long as there's water, the plant can photosynthesize and make its own food. So no big deal, even if its food carrying tubes get cut, unless it got cut at the point whereby there are no leaves, okay? There are no leaves below it, okay? Then in that case, that whole bottom part of it being cut is just gone. So what am I talking about? So imagine these are the roots, these are your tree, okay, and then this is your tree leaves. If it gets cut here, the food carrying tube, no big deal. Okay, the water carrying tube is still intact. Whatever that is here, it can still make food. They can still receive water and make food on its own. And whatever that is at the bottom here will receive food from the other parts that are still functional. But if you cut it here, the food carrying tube is gone. It doesn't matter anymore. because below this part, there is no leaves, okay, to actually carry out photosynthesis. So this part over here is as good as dead, because the food carrying tubes are cut. It cannot receive any food that is made by the leaves above the cut, and so the roots will eventually die. You cannot absorb any water anymore. Eventually the whole plant will just be dead. Next, what is the function of part X? This is a function question. This is actually a definition question. You have to memorize it by heart. So we know that part X is transport function. So when it comes to anything that has a transport function, I've repeated many times, you have to tell me what is the substance that's being transferred and from where to where. Okay? So part X. So part X, so X is the phloem. You don't have to write this part, but it's good. Okay? It transports. It transports food from the leaves to all parts of the plant. Okay, so what are we looking for? Food from where and to where. Okay, next. The scientist sprayed substance M around the plant, which produced a smell that repelled the adult insect. After a month, he observed that the population size, okay, of the insect on the plant decreased. Give 2 reasons for his observation. Now, when you talk about population size, I need you guys to focus. It does not just talk about the adult. When we talk about population size, it actually talks about both, okay, the young and the adult. Correct? It doesn't matter, ma. As long as if it's the young, it's also counted as part of the population. So the first reason is very simple, very straightforward. Okay, the smell basically caused the adult to move away. Okay, so the smell repelled the adult and caused the insect to move away. Right? Okay? Very straightforward. The second reason, when the eggs of the insect hatched, the young grew into adults and moved away due to the smell. Okay, so because the adults move away, eventually whatever eggs that's remaining when they hatched, they grew up, and then they become adults, they move away. Because why is the adult part important? Because they actually tell you that only the adults will be repelled. So it's important to tell me that the young has grown up to become the adults. But eventually the overall population will decrease because no more adults to lay eggs. So after a period of time, eventually it becomes 0. Okay, that is the goal of this substance M. Next. Okay, the diagram below shows 3 organisms in a garden community. The caterpillar feeds on the leaves of the tree, bird eggs feeds on the caterpillar. The tree and the bird eggs depend on each other. Okay, so they depends on each other means what? It's a benefit. They benefit each other. How does bird eggs benefit the tree? So obviously, bird eggs is eating the caterpillar, and the caterpillar is eating the leaves. So the first thing would be that the bird actually preys on the leaves. So there is more leaves for the plant to now photosynthesize. Okay? So as bird eggs or as eggs preys on the caterpillars, the tree will have more leaves to photosynthesize. So you cannot just say that the bird eats the caterpillars, full stop. That is actually like a cause. So what's the effect? The effect of that is that, the trees will have more leaves. So how does that benefit? That can photosynthesize more, and photosynthesize means more food. Next, other than the availability of food, how does the tree benefit bird eggs? So don't forget, usually what do birds do on trees? This is a bit of a general knowledge. So remember I told you when it comes to survivability, there are three things you look at. Increase in food, which is what the tree has already been doing already. It provides it with caterpillars indirectly. Okay. The second thing would be what? Defense. Correct? So it either provides the bird with a shelter, or it provides the bird with a place to build its nest. Okay? And no, it's not reproduction in this case. So some of you were thinking, oh, nest, is it reproduction? No, it's not. Reproduction is, for example, like the bird will have like attractive, colorful feathers to attract, the opposite sex of the birds. Okay? So the tree provides shelter for the bird eggs. Okay? Next. Now the diagram show how bird Y catches fish for food. Okay, it swoops down. Wings are folded. The wings of bird Y are spread out when it's flying. It will fold its wings when it dives in the water. State this adaptation and explain how it helps, bird Y catch its prey in the water. So basically this one, right, is talking about streamlined body shape. Okay? It helps Y to have a streamlined body shape. Okay, this enables Y to move faster to catch its prey. Okay, so in this case, I don't say swim faster because birds don't really swim. Okay, use the word move. I think it's more appropriate. Next, Jenny prepared a container which has a capacity of 200 cm3 for an experiment, meaning that it can hold a maximum of 200 cm3 before everything spills out. So the maximum is 200 cm3. She filled it with 120 cm3 of water as shown. Alright. Next, she added 2 metal cubes with a volume of 30 cm into the container. So basically, what is remaining here, alright, is only 80 cm3. And then each of this is 30. I'm not putting the units because not enough space already, okay? So whatever that's remaining here now, if you take 80 minus away 60, okay, 80 minus away 60, the remainder is actually only 20 cm3. Now, Jenny noticed that the water level increased. She wanted to add another identical, means add another 30 cm3, okay, without water overflowing. Is she able to do it? Straight away the answer is no, because there's only 20 cm3. Okay, water has a fixed volume, you can't compress it. So if you add in another 30 cm3 inside, definitely you have an excess of 10 cm3 of water which will come overflowing onto your tabletop. Okay, so in terms of matter, so be very careful, okay, in terms of matter. So what must you say? You need to tell me that the cubes have definite shape. Sorry, the cubes have definite volume or fixed volume and cannot be compressed, right? Okay, while I'm talking about this, I want you all to know, okay, when they ask for properties of a liquid, a lot of you, okay, or properties of a gas, okay, while we're on this topic, you would say things like, oh, the gas can be compressed. That is not a property actually. The property would be a gas does not have a fixed volume. That is why it can be compressed. The fact that it can be compressed is an outcome or a consequence of the gas not having a definite volume, if you know what I'm saying. Okay? So, because it has a definite volume, okay, the cube will occupy more space than what is available in the beaker. Hence, the water will overflow. Okay, next. Jenny poured the contents of the liquid through a funnel into a basin as shown. She observed that the two metal cubes stayed in the funnel. Alright? Explain in terms of properties of matter how the metal cubes were separated from the water. So ask yourself, how come this one cannot flow, this one can flow? Well, the answer is because water does not have a definite shape, so it can fit through the gaps. Okay? There will be some small little space here, okay, that your water can flow through and go into, whereas your metal cubes, they are rigid, okay, they have a fixed shape. So how can we say? So the cubes, which is a solid, has a fixed shape and cannot fit into the funnel. The water, this is liquid, does not have a fixed shape or definite shape and is able to pass through the funnel. Okay, next. The volume of metal cubes increased when Jenny heated up the metal cubes. She concluded that the mass of the metal cubes also increased. Okay, do you agree with her? Explain. Obviously, no. Okay, so when you heat something up, what happens is the particles that makes up the object actually move further apart from each other. Okay, so let me give you a very simple example. So if let's just say I have a solid that is made up of 6 particles. The initial spacing between every one is so much. But when I heat it up, it becomes bigger. Why? The number of particles did not increase. The size of the particles that makes up this particular object also did not increase. What increased was the distance between each particle. Okay, so remember, the definition of mass is the amount of substance that makes up a particular object. The amount of substance. So in this case, if there are 6 and this part also 6, it didn't increase at all. Okay, so it's just no. The mass of an object does not increase during expansion due to heating. Okay, Next. Kelvin conducted an experiment to find out where water droplets would form on two identical glasses of milk at different temperatures as shown. So basically this is your change variable. It is very important to identify. Do not be complacent. You have to do that. She placed 2 glasses of milk on the table at 30 degrees for 10 minutes. So what is the change? Temperature. Predict where the water droplets will form in both setup after 10 minutes. I want to tell you the place that this will form during condensation, and when you see water droplets, it hints you that it is condensation. In water cycle, there are 2 processes that you need to know. One is evaporation, one is condensation. It's always the fixed. If you see water droplets, condensation has happened. Okay? And where condensation will happen, it always happens on the cooler surface. So basically, you just need to identify your cooler surface and you will know where is it. So for example, for setup A, right, you take a look at it. The milk is at 5 degrees. So no need to say already, this whole part here would be cold, right? So I'm going to use blue. This part here is the coolest. Okay, because it is in contact with the cold water. Some of it may condense here at the sides as well. Why? Because heat is being lost from these parts as well. However, the majority of it should be at these areas, because this is where it is the coolest. And where is the source of water vapor, the warmer water vapor? From the surrounding air. So what happens is that when the warmer surrounding air touches, okay, the cooler, it's a part of the glass, it will start to condense into liquid water droplets. So in reality, right, you may get a few drops here, okay, sometimes even here. It depends on how cold, in real life situation, but the majority of it will be at these 2 parts, because this is the coolest. Okay? Next. This one over here for this side. Okay? Now, at this part here, over here, right, where is the cooler surface? The cooler surface is over here. Okay, in comparison to the warmer water vapor, which is actually here. How come the warmer water vapor is here? Because you have got very high temperature liquid. So the water will evaporate, and then the surrounding air that is inside your this glass has warmer water vapor. The place that is the coolest. Okay, I'm not saying that this is not cold. I'm not saying this is the cold. Okay, I'm just saying that it's the coolest, because when you compare this surface to the surrounding warmer water vapor, this surface will be at a lower temperature as compared to this. So therefore, when it touches the cooler surface here, it will condense and become water droplets. You will lose heat and condense to become water droplets. So you may even find a bit of water droplets on the inside part. So the difference is that this is on the outside, this is on the inside. Okay, I hope I'm clear. So for A is at the outer surface of the glass X. Okay, and set up B is at the underside of the metal cover. So I'm just talking about mainly, okay? Now explain how water droplets are formed in setup B. This is easy peasy. We have already done this 100 times. So it's a water cycle question. You would want to be able to identify the source of your warmer water vapor. Okay? So now that you have already identified that the water droplets is going to condense over here, so this must be your cooler surface. Where is your warmer water droplets? It's actually here. okay, inside the glass because the water here would have evaporated. So how are we going to craft this answer? So in this case, you don't have to say gain heat because the water is already hot, okay, it's already warm. So all you have to do is the water in the milk evaporated into warmer water vapor. Okay, then after that what happened? The water vapor touches the cooler surface of the underside of the metal lid, lost heat, and condensed into water droplets. Okay, there you have it. Next, last one. In setup B, how will the amount of water vapor change if the metal cover is replaced with a plastic cover? So the key thing here is this is the change variable. So you compare what's the difference. So when it comes to condensation, okay, remember water droplets, right? So this tells you that I'm concerned with condensation. So what affects the rate of condensation? Rate of heat loss. The faster the heat is lost from the water vapor, the faster it will condense. So given that plastic is a poor conductor of heat, okay, when the water vapor touches the plastic, it will lose heat slower. It's a comparison. So because heat was lost at a slower rate from your warmer water vapor, it will condense at a slower rate. Okay, so what are we looking at? How do we pen this answer? You would say that less water droplets is formed. Okay, why? The plastic cover is a poor conductor of heat compared to the metal one. Hence, the water vapor will lose heat at a slower rate to the plastic and condense into water droplets at a slow rate. So you need to be very careful because it's always slower, less, okay? Because it's a comparison question. So you need to make sure that you have that, okay? All right. Question 35. Mary wanted to find out how gases P, Q, R, and S affected material Z. Okay? She set an experiment as shown. So what is the change variable? The change variable would be your P, Q, R, and S. Okay? So apparently, right, the measured variable in this case is actually your mass of material. So what did she do? She released gas P from its container completely into the tank of water. This mixture of gas P and water was then released into a beaker which contained 100 grams of material Z. So what happened is they bubbled, okay, this gas and got it to dissolve into the water. So now this liquid actually contains the gas in question, whether it's P, Q, or R. And then they let it into this material Z. So apparently, right, what happened is that the one that is most corrosive, or the one that actually removed the most amount of mass, right, would be your Q. Because the remaining amount of mass, okay, was the least. So this tells you that Q corroded, okay, this particular material. In real life, right, think of it as in like rust. That's why certain metal, they say when it's wet, okay, like for example iron will rust. So why? Rust under oxygen and water. These two will cause it to rust. But of course, there are other things that are also very corrosive. Next type of gas used. Okay, so remember, in fact test there is only one change variable. The variable that you're supposed to change in this case is actually the type of gas. Other than that should be all the same. So they ask you what must keep the same. So your answer should be the mass. Okay, sorry, not the mass, my apologies, not the mass, amount of mixture and amount of gas. The mass of the material, this is actually your results. This cannot be kept the same because it depends on the outcome of the experiment, and this is your change variable. So these two you cannot keep the same. So based on her results, what can she conclude about all four gases? So out of these four, you realize that there's a few trends. Okay, there are actually 3 trends here instead of just 2. Nowadays, I've told you many times, PSLE they like to test 2 trends. Usually it's 2 lah, but in this case it's 3. What are the 3 things you need to mention? Firstly, you need to mention that your Q is actually the one that's most corrosive, or is the one that has affected, okay, the amount of the mass of the material Z the most. Okay, then you have to mention that out of the 3 P, Q, S, they all cause your mass of material Z to decrease. Okay, and then you also have to mention the third thing would be that your R has no effect on material Z. So it's 3 things in this case, 3 key points. Alright, usually it's 2, but this one is 3. That is at least how I would have answered this. Okay? So you would say that okay. Material, alright. Okay, material R, okay, gas R has no effect on material Z, on Z. Okay. Gas P, Q and R on S, sorry, causes Z to decrease in mass with, then the last one is Q, sorry, not Q, not, that's wrong. With Q decreasing Z the most. Okay, so there are 3 things that you need to know. One is no effect. The next one over here is which are the 3 that causes it to decrease in mass, and the last one would be Q causes it to decrease the most. Next, the shell of organism X is made of material Z. A mix of gases P, Q, R and S are found in acid rain. Explain how acid rain is harmful. So we're talking about acid rain, right? So you need to refer to your previous question. Okay? Over here. So you know that probably, alright, they said that P, Q, R, S, all 4 is actually in the acid rain. Out of these 4, you know that P, Q, S, 3 of it actually will dissolve away the material Z. So because of that, you have to say that it will damage, destroy, dissolve any to that extent. So that is cause. So now the effect. So remember when I talked about adaptation, I'm always talking about 3 important things. It's always either increase in finding food source, increase in defense, or increase in reproduction. Okay, success of reproduction. So in this case, it is not food, it is not reproduction, it is actually your defense. Okay, so acid rain will damage or destroy the shell of X. Hence, X will not be able to hide from its predators. Okay, so we're talking about shelter in this case. Okay. Next. Okay. Harlin placed two identical metal rings XY through a rod as shown. He observed the two magnets were at distance h. So this tells me that it's actually repulsion between these two. So no need to CAD because they are both magnets, so they have poles. The only way if they will repel is if, let's just say, these two, okay, are like poles facing each other. This word facing each other needs to be there, if not 0 marks, and hence they repelled. Now remember, we have thought through this already. I have checked with all the other teachers, we have agreed. Okay, so like previously what I told you, if it's floating, the correct answer is to say that the repulsion force of the magnet is equal, okay, to the gravity. So that's why it's not moving, it is just suspended. Okay, greater than gravity means it's going upwards. It's still moving upwards. Alright, and it has not stopped moving upwards. And then overcame gravity, which is not in your syllabus, means it went to outer space already. It is not within the pool of gravity at all. Okay, so these are the different three. State the forces. We all know as long as on Earth you have gravity, that's one of gravitational force. The next thing is actually your magnetic force. Okay, these two. Now, what happens if you put a steel ring? So a steel ring, right, generally, right, it doesn't have any poles. So it will definitely be stuck on to the next part over here, just stuck on it, on top of it. So what purpose does it serve? It serves to add mass. Okay, and remember, when there is more mass, you get more gravitational force acting on it. So because of that, it will be pulled downwards. So because when it's put downwards, your H will actually decrease. The distance between magnet X and magnet Y will now become smaller due to the additional mass over here. Okay, why? How does it affect? Now magnetic Y together with the steel ring is considered as one item, and so their mass has an increased gravity acting on it. Okay. Alright, so you will need to say that H decreased. So the steel ring added mass to the magnet X. Hence, there is more mass. Oh, sorry. Hence, there is more gravity acting on X. Alright, so because of that now more weight of X is acting against gravity, against magnetic force. Reducing H. Okay, H is the distance. continuing on to the next question. So whenever there is a question, usually they are related. So if we take a look at this question, right, this kind of is resembling this in a way. So the plant is like your steel ring, okay? It adds weight, okay? And then after that, these two must be magnets somehow. All right, so describe how the floating pot works. So because the pot is floating, we know that there is repulsion. This must be a magnet. This must also contain a magnet, okay? And the repulsion, okay, the repulsion, all right, is pushing each other away. The repulsion is also opposing one very important force, and that is your gravity. Okay, your gravity is pulling it down. Now, because the pot is floating, it's not moving anymore, we say that the repulsion force of the magnet, okay, is actually equal to the gravity pulling it down. If we say it's greater, it means it continues to go up. And if we say it overcomes, it means it goes into space. I cannot repeat myself any more time, okay? But I just want to be extra sure that everybody understood what I'm trying to say, okay? So we would say that, okay, let's translate that into an answer. We would say that the base contains or has a magnet. Okay, so the magnet let me redo this. The light poles of the magnet at the base and the electrode and the floating pot are facing each other. This is important, and repelled. Then you have to say that because this is it causing it to float, you have to talk about the force being equal. The magnetic force, magnetic repulsion force is equal to the gravity pulling down on the pot. Hence it floats. Hence the pot floats. Okay? Next. It was observed that the floating pot will stop floating and drop to the base if its mass was greater than 2 kg. Suggest a way to allow the pot to continue flowing. So there is a few ways, but one of the most obvious one is to use a stronger magnet as the base. Or you can say use a stronger electromagnet of the pot. Okay? So the greater the electromagnet, the greater or the repulsion force. Next, Wayne set up an experiment as shown to investigate the property of 4 rings made of material J, K, L, and M. For each string. For each string, he added weights until it broke. Okay? So if you see things like that, straight away you know that in your mind you should come to you that, hey, this experiment is actually trying to find out how strong, okay, strength, is testing the strength of various strings, okay, materials that makes up the strings, okay. So his results are shown in the table, and then these are the results. So this is your measured variable, and this is your change variable. Which property of material is Wayne testing for? Strength. Okay, like what I told you. State one variable of the string that Wayne must keep the same to ensure a fair test. Many things, but one of the most obvious would be thickness of the string. Okay, and be very careful. They're talking about variable of the string, alright, and not anything else. So if you say things like, oh, must be conducted in the same location, temperature must be the same, it doesn't really make sense. Or even say things like, oh, what's that thing called? These two stands need to be the same material. You're not answering the question if you do that. It has to be thickness of the string, okay, or something to do with the string. Now, a grocery bag is used to contain heavy groceries purchased from a supermarket. Now, when you look at these, right, the keywords like heavy is a key thing to you, and there are many times that students tend to ignore such important details. Because they use the word heavy here, it tells you that your answer, you need to address the term heavy. Okay, so based on the results of Wayne's experiment, which material is the most suitable to make grocery bag? Explain your answer. So because it's you have choice, alright, so that's CER, but they also have a usage, so therefore it's plus one more U, CERU. So in this case, your C, right, would be that, if you look at it, your answer should be L, because L is able to hold the greatest amount of weight before it broke, so it is the strongest. Alright, so I would say that L. And then what's my E? My evidence is that it can hold the most. Remember, it's comparative amount of weight before the string broke. Okay, and R. Reason, this suggests that L is the strongest. Remember, we're testing on strength. Once again, make sure your comparative terms is there. Material. And then the last one, U. By using L as the material to make the bag is able to hold heavy things without breaking. Okay, next. Sam pushed an object over the same type of surface from point X to Z all the way to here, okay? As shown in the diagram. Sam needed more force to push from Y to Z. Explain why. So what is the difference? Always, okay, so here's the key thing, class. Whenever you're presented with two scenarios, scenario A, scenario B, always ask yourself, what is the difference between scenario A and scenario B? That will give you a hint to the answer. So between scenario A and scenario B, okay, we know that one is horizontal and one is sort of going upwards. So the difference is that, okay, your object, when it's from X to Y, is not going against gravity. Okay, whereas from Y to Z, it is going against gravity. Gravity is going down, you are trying to push the object up. So because of that, you need more force, correct? Because you're going against gravity. Okay, he is pushing the object against gravity. Okay. Next, without having another person to help Sam, suggest a method to help him to reduce the amount of force needed to push the object. So basically, what you can do here is you want to reduce the force that is acting against the object. Now there are two forces that's acting against the direction of the object. Firstly is gravity. Sorry, 1 second. The second thing that is acting against it is actually friction. Right? Because you're moving the box in this direction, you are actually going against it. You can't really reduce gravity unless you have some supernatural power, okay? Or you cut the object into half because you have reduced the mass. You can't do that. So basically, the only way you can do it is to reduce your friction. So how can we reduce friction? We use something called a lubricant. And whenever you mention the word lubricant, I've told you this many times. I've told you once, I told you twice. You have to at least state an example. Apply a lubricant such as oil or water onto where? Either onto the object or onto the surface. Okay? From Y to Z. So let's pen that down. Okay, apply a lubricant such as oil, okay, on the object. Okay, sorry, underneath the object. Under the object. Next, explain in terms of forces how your method stated. So we're talking about friction, right? So for friction, make sure you tell me it reduces friction between what and what. Once again, you cannot say it reduces friction on the object. That's it, full stop. Cannot, because friction is a contact force. It needs two surfaces rubbing against each other in order to be present. Alright? So you would say that, okay, the method above reduces friction between the object and the surface from Y to Z. Okay, next. Now study the diagram circuit of A and B. Add another bulb to circuit A such that both circuits, okay, are brighter than both bulbs in that circuit. So the that circuit refers to A, are brighter than the bulbs in B. Draw bulbs and wires in circuit A. Now, if they didn't tell you what type of bulbs or switch or whatever components to draw, if they say draw bulbs, make sure you use symbols. Okay? So basically, you need to add one more bulb to A, and you want it to be brighter than B. So obviously B is in series. Now, once again, I'm very quickly going to revise these out. If, example, this is 10 units of brightness, alright, this two over here will be 5 unit and 5 unit of brightness, because the electric current needs to pass through both. Okay? Now, if you were to add another one more, okay, in a parallel manner, like this, like so, this is 10U. The initial bulb will not be reduced in brightness. So what is the consequence? The consequence is that your battery will get drained at a faster rate as compared to B. That's the first consequence. The second consequence is that, which is a good consequence, should one of the bulb be fused, okay, the circuit is still closed for this particular bulb. That's how you phrase it. So you can say that bulb A is still in a closed circuit even though bulb B has fused. Alright, the key idea when answering questions related to parallel is tell me which electrical component is still in a closed circuit. Alright, once again, if this is B and this is A, bulb B, and B fuses, you would say even though bulb B fuses, bulb A is still in a closed circuit, as the electricity has an alternating pathway. Okay, hence bulb A will still remain lit. Alright, so that is another positive consequence of putting your bulb in a parallel arrangement. And make sure you say bulbs in parallel arrangement because it's the bulbs that are parallel to each other. Okay, can you see? I'm sure you all learned this is math in math, right? Okay. Next, the diagram below shows a house with 3 rooms. Okay. Now, complete the diagram such that the bulb in each room is controlled by a switch in each room. Turning off and off in any room should not affect. So this tells me that all the switches is in parallel arrangement. Now, when you draw the electric circuit, right, make sure that the switch is in the individual rooms. Okay? I mean, come on, it doesn't make sense for you to put the switch in this room. So I'm going to say this is room 1, room 2, room 3. You cannot have 2 switches, both switches in room 1. And then after that, the switch to control room 2 is still in room 1. It doesn't make sense. So how do we draw the switches? Hint. I would draw the switches as close as possible to the to my bulb. Why? So that I know that this particular switch controls this bulb. There's no other way. Okay? So when in doubt, draw it close, especially when they tell you already, it controls individually. And then the next thing is, I will then draw where is my main line. Draw in my main line. My main line is actually the one in red. Okay, wait, I just want to make an edit. Give me a second. I think it makes a little bit more sense if I do this. Yes, like this. And then I place my switch here. Okay. Now, what are you checking for? You are checking to make sure that there are no gaps. Any gaps will definitely give you a deduction of marks. Make sure your switches is arranged parallel. Okay, check. So this one is this way. Then the next one is this one. And then the next one is this one. So can you see? 1, 2, and the last one, 3. Okay? And of course, use a ruler where possible. Next, study the diagram. Explain in terms of energy conversion how heat energy causes the spiral to spin. Okay? Now, in this case, we're talking about energy. So energy here, you need to actually have some form of conversion. So once you see energy, and they ask you to explain, you definitely need to tell me about conversion. Okay? It's not so much about expansion in this case, but it's really about energy conversion. And of course, the word spin will tell you that what kind of energy is present? Kinetic energy. So somewhere along your lines, you need to tell me kinetic energy. Okay? So let's take a look. Now, in between here, there are actually air. Air is between the flame and the spiral. So what needs to happen is you need to tell me that the heat energy, okay, is converted to heat energy in the air. And because of this heat energy, right, the air will start to move. So when it moves, okay, it will then touch or push the spiral, which then converts to the movement of the spiral. So when you are talking about energy conversion, and this is where many of you will make the careless mistake, you must tell me location of the energy. You cannot just go, okay, kinetic energy, more kinetic energy will be converted to more kinetic energy. I don't quite understand. Or more heat energy will be converted to more kinetic energy. Of where? Of what? You have to tell me more heat energy of the candle or of the flame is converted to more kinetic energy of the air surrounding it, which is then converted to more kinetic energy of the spiral. It needs to be that way. If you don't tell me the location, you don't get the marks, because there could be more than one item or more than one location where it has kinetic energy. You have to identify that. Okay, so heat energy of the flame is converted to heat energy of the air. You can use transfer also. This heat energy in the air is then converted to kinetic energy of the moving air, which is then converted to kinetic energy of the spinning spiral. So take note, anything that has movement, I use the ing form. Spinning, moving, okay, these are all kinetic energy. Alright? Now, some of you may be thinking, how many conversion must I actually talk about? Talk about the main conversion. If you write a little bit more, it's okay. You will not be penalized as long as it's correct. Okay, just like some energy is negligible. So for example, when you actually, let's just say you throw a ball, okay? So you know it's movement, right? The majority of it is actually kinetic energy when it's moving through the air. But actually, there is a small amount of heat energy. Why? Because of the friction between the ball and the air, okay? So that's not the main energy. The main energy is kinetic energy. If there's no gap in the setup, the spiral will spin very slowly. Explain how the spiral of gap allows the spiral to spin faster. So where's the gap talking about? Over here. Okay, so this gap actually allows more air to enter. So when more air enters, it gets heated up more, and then after that, the spiral will spin faster. There is a higher order alternative answer, okay, that not many people may know about it. And that is, okay, when you burn anything, you actually need oxygen. So when you have a gap over here, it could potentially increase the amount of oxygen flow. So your flame becomes bigger. That's why when you see people barbecuing satay or when they are barbecuing, they tend to be fanning the flames. You're actually feeding the flame with more oxygen so that the combustion or the burning rate can be higher. Okay? And that's, okay, I'm just telling you an alternative answer that is also correct. So let's translate the first one, which is more air can enter. Okay? So the gap allowed more air to enter and be heated, so that more heat energy of the air can be converted to more kinetic energy of the moving air. Okay, next. Okay, that's the end of the paper already.